And welcome back to another video on slug tests. And again, this one is the first one showing a method to calculate aquifer properties from slug test data. So the last one was just a general introduction, a little bit of theory. And here we are. So you can see here that once again we have type curves basically, right? So these are type curves that you can see here. That represent, the typical slug test data for different parameter mu. So this parameter mu here is, again, the screen radius, so the radius of the screen squared divided by the squared radius of the casing. So if they're different, right, this ratio is different. Obviously, if they're the same, then, that goes away and it's 1. And the storativity S, right? So now we can get the storativity once we fit our data to those type curves, basically, right? Once we know mu, we fit the data to those type curves. We read what mu is. If we know mu, we know S. So let's do an example, right? So notice that on the x-axis, it's actually eta, it's not, so for eta is 1, so this is eta here. So for eta is 1, we have this equivalence TT equals RC squared, right? So what we want to do is first line up the data on the type curve, then identify mu, right? So mu's are here. You can see this is log 10 mu, right? So depending on where our data fits, let's say if it's here, then that means that log 10 mu is -2 for this data, okay? So again, first we line up the data, second we'll read mu, and 3, we want to read the data at this point where like TT equals RC squared. And I'll show you why before, because then we can actually get the transmissivity. Okay, so let's do it. So now we lined up the data. So again, when you line up data by hand, what's really important, and oftentimes that gives students a hard time, remember to get those scales proper, right here. So of course you want your x-axis and your y-axis on the type curve and on the data to have the same, right, the same shape basically, right? Because you're lining up things so your x and y need to be the same. And believe me, that seems maybe a little obvious, but a lot of people struggle because, their x-axis and their y-axis don't have the same scale and they don't know how to do it basically. So the trick here is to just rescale, until your axes have the same scale. Basically, you need to have the same scale so you can line up the data. Anyhow, in this case, we're lining up on log mu is -3, and you can see there's a little bit of noise, right? So it's not a perfect fit, but it's pretty good. So we're saying that log 10 mu equals -3, so mu equals 10 to the -3. Okay, so we have our first number that we need. Then again, draw the line for n is 1. So this is where, eta is 1 right here. And now what we'll want to do is read the time on the x-axis from the data. So I just blew that up on the next slide here so you can see. So this is where eta is 1 was. And now we can read this time, and that looks like 10 to the 1 is 10. So we're between 10 and 20 somewhere, right? So 13 seconds on the x-axis. Okay, so now we have, around 15 seconds. It's between 10 and 20 somewhere. So we do have mu, we do have t. We're good to go and plug it in some equations, right? So now we have everything. So look at this. We know the casing radius, presumably is given, right? It's actually given right here. We know the time, we just read it right here, or actually 13 seconds. So we know eta equals 1, because by definition, that's where we read that number. So now we can go ahead and calculate t equals, and I leave this as an exercise. Similarly, we know mu, right? Mu was 10 to the -3 right here. So we have mu 10 to the -3. We know what the screen radius is. We know what the casing radius is. So the only unknown now is S, the storativity. So we can calculate the transmissivity and storativity for that aquifer. Okay, so this is how we use the Cooper method to find aquifer properties from slug tests. In the next video, I will show you a different method, which is the Vorslev method. Thank you.